All right, Chan, you got to the end, and now you're just doing these last three problems. And so what are we looking at? We're looking at what happens if they're asking us for speed when we throw the ball up. And what we learned in class was, right, that if we throw the ball up, we know the ball is going to start getting slower and slower as it moves up. It's going to eventually hit this point right up here where its velocity is going to be 0. And then it's going to start moving faster and faster as it goes down. And so we'll always still use negative 9.8 for the acceleration. We'll always figure out the time based on what they tell us. Velocity, final velocity will always be the time, the velocity. And the only thing that's going to be different is that we're going to be given an initial velocity that's not 0. Okay, it's going to be whatever they threw it up at. And we'll remember that if we get a positive number for this, that means the ball is still going up. If we get a negative velocity, that means the ball is going down. So let's do a couple of quick examples, just so that you know what you're doing. We got a baseball hit straight up in the air with a speed of 24 meters per second. And they're asking us to find the speed at different times, right? So remember, they're asking us to find the speed. So we're always going to use the speed equation, VF equals VI plus AT. All right. And so if they ask us what's the ball speed after 1 second, we'll do it up here. Well, VF is what they're asking us to find. The initial velocity, not 0 now, 24, right? Because it's thrown up at 24. So we'll put in 24 plus negative 9.8, right? Always for A, negative 9.8. And then the time that they gave us, which is 1. All right, do that math real quick. I think it's equal to 14.2. Okay, how do we read that? Well, we know that the ball is going to start going up fast, and then it's going to slow down, and then it's going to come back down. So the ball must be somewhere like maybe right here, right? Still going up, but slower than initially at 24. What about after 2 seconds? Well, we don't just plug it into our equation. We write down VF equals VI plus AT. Remember that it's thrown up at 24, so that's a positive number, plus, and then a negative 9.8, this time times 2. Okay, do this math, we'll put that into our calculator, and we're going to get a number like, I'm going to guess 4.4. Okay, still positive, but much slower. It must be somewhere over here. All right, and then after 3 seconds, VF equals, again, it started at 24. Now they're asking us for 3 seconds, negative 9.8 times 3. All right, and I'm guessing that that's going to be 5.4 is my guess. Okay, but now it's negative. Negative 5.4 must mean it's down here somewhere. All right, so we've got that equation, and there's just 2 quick questions about Romeo's flower. It wants to know what's happening on. And at the end, they give you a challenge question. It says, how long does it take to reach the top of the path? Remember that our trick right here, how long does it take? So now they're asking us to find the time. So in this equation, we know we have been given VI, we know A because that's the same on Earth, and we need T. So they must have hidden the velocity, the final velocity, somewhere in this sentence, and that's right here. It's at the top of its path. And what's the velocity of something at the top of its path? It's 0. So if we write this equation, VF equals VI, and we hit 0 equals 24, right? Plus negative 9.8. And then he asks us to find T. So we'll leave it as T. And then we have to solve that, right? And hopefully you'll remember how we solved that in class, but we subtract 24 from both sides. We get negative 24 equals negative 9.8 T, and then we divide by negative 9.8 to find T. All right, have a great weekend, Chan. I'm glad that you guys are doing your homework.